Here we go with limiting reactants, practice problem number 4. I've already balanced the equation for you. I also underlined all the key terms that you're going to need to know. 104.2 grams of potassium nitrate, 207.1 grams magnesium sulfate, and we are solving for potassium sulfate. So this product right here, we're not worried about magnesium nitrate. We are just worried about potassium sulfate right here. And then we want to, of course, discover our limiting reactant. So after we balance the equation, we now need to convert our grams of reactants into grams of product. So we can do that by starting off with 104.2 grams. And for potassium nitrate, I'm going to abbreviate it KN strictly so we have enough room to fit it all on this page. So 104.2 grams of potassium nitrate. We have to convert that to moles first using its molar mass. Potassium nitrate's molar mass is 101 grams per mole. So that equals 1 mole of potassium nitrate. Then we have to go to our mole-to-mole ratio that we get from our equation. So how many moles of KNO3 do we have? We have 2. 2 moles of potassium nitrate is equal to how many moles of potassium sulfate? Equal to 1 mole of potassium sulfate, because there's no, and I'll abbreviate that as KS, because there is no coefficient in front of it, so that way we know it is 1. Now we have to convert from our mole ratio into grams of potassium sulfate. So we have 1 mole of potassium sulfate is equal to 174 grams of potassium sulfate. So that is a large polyatomic ion. We then multiply straight across, so we get 104.2 multiplied by 174. And then we divide that by 101 times 2. 1 times 2. You end up with 89.75. We'll go with 89.8. Round up. 89.8 grams of potassium sulfate that we are producing with 104.2 grams of potassium nitrate. So my next given is 207.1 grams of magnesium sulfate. So always two-dimensional analysis portion, so 207.1 of, I'm just going to put MGS for abbreviation's sake so we can fit everything onto the screen. Set up my dimensional analysis. Molar mass of magnesium sulfate is 120 grams MGS, and that is equal to 1 mole MGS, just like that. And now we have to use our mole-to-mole ratio that I would get from up here. There's no coefficient in front of magnesium sulfate, no coefficient in front of potassium sulfate. Therefore, 1 mole of magnesium sulfate is equal to 1 mole of potassium sulfate, because there's no coefficient. So that is why it is 1 on both. And then we convert using the same conversions as we did over here. 1 mole of potassium sulfate is equal to 174 grams of potassium sulfate. And then we multiply straight across and divide. So we have 207.1 multiplied by 174. And then we divide that by 120 times 1. So we just divide that by 120. We end up with 300 grams of potassium sulfate being produced by our magnesium sulfate, which means we always go to the one that is less. So we look here, we look here, 89.8. This is how much potassium sulfate is actually produced. So that is our actual answer, because you always go to the lower number. That's how much is actually produced. And therefore, our limiting reactant would be potassium nitrate. The 104 grams of potassium nitrate only produced 89.8 grams of potassium sulfate. So that is our limiting reactant. And those are your 2 answers for practice problem number 4.